Hello students, let's read this question. Which table best represents the data of the following equation? I like these questions, are very straightforward. Okay, so they want to know from the table the one that represents the following equation, which is this one. Okay, so we underline already and I just want to know my question and I need to know the table that represents this equation right here. With a circle and underline, with box, elaborate. For elaborate, what I'm gonna do is, if I have a table, I know my first step was what, guys? Remember? Find the pattern in each table, on the table, but in this case we have several tables. We need to figure what the pattern are to see if they represent a constant rate of change. So that's what we're gonna do first. Let's get started with table A, and that's our section of elaborate. Remember, step one, and I'm gonna write it right here. Step one is find the pattern on Y and on X. And for Y, I've been using orange, and for the X's, I've been using blue. So all this will be the blue, the left sides, and the right side, I'm gonna represent the changes on the y-axis. Okay, so let's get started with choice A. For choice A, I'm gonna check from 2 to 5, the difference is plus 3. From 5 to 10, plus 5. From 10 to 15 is also plus 5. And from 15 to 20 is also plus 5. So in one of the choice, in one change is not constant, but let me see what's going on the other side. So from 184 to 140, it's going down, so it's not going to be positive, it's going to be negative. Now I can subtract straight from here, guys. 4 minus 0, that's a 4. A minus 4, that's a 4. And 1 minus 1, that's 0. So I don't have to write the 0. Okay, the difference from 184 to 140 is negative 44. Now let's check this one here. From 140 to 120, what's the difference? Negative 20. Or we're going down 20 units. From 120 to 70, what's the difference? We're going down 50 units. And from 70 to 40, we're going down negative 30. And before I analyze this one, I'm going to keep going. I'm just going to remember my number. This one was plus 3, plus 5, plus 5, plus 5. And on the other side, they were all different. Does that make sense? Does that look like a constant rate of change? Right? Okay, think about it. Now let's check table B. Let's go from 2 to 5. The difference is plus 3. From 5 to 10, the difference is plus 5. From 10 to 15 is plus 5. And from 15 to 20, it is also plus 5. Now let's check on the y-axis. From 184 to 160, and I'm going to subtract straight forward from here. 4 minus 0, that gives me 4. A minus 6, that gives me 2. And 1 minus 1, that's 0. And it's negative because it's going down. From 160 to 120, the difference will be going down 40 or negative 40. From 120 to 80, we're going down, and the difference is 40. And from 80 to 40, it's going down 40 units. This is 0. Okay, great. Now look at this. Look at the numbers. On the left side, we have positive 3 goes with negative 24. But then all the other ones got all 5s and all negative 40s. Okay, let's check what's going on with C. From 2 to 5, plus 3. From 5 to 10, plus 5. From 10 to 15, plus 5. And from 15 to 20, it is also plus 5. Now let's check on the y-axis. From 200 to 150 is negative 50, going down 50 units. From 150 to 100, we're going down 50 units. From 100 to 50, we're going down 50 units. And from 50 to 0, we're going down negative 50. And look, guys, what's going on here. Here we have a different change on the x-axis, then the change was the same. And on the other side, all the times that difference was negative 50. So 50. Okay, good. Now let's check letter D. From 2 to 5, the change was plus 3. From 5 to 10, plus 5. From 10 to 15, the difference is plus 5. And from 15 to 20, the difference is also plus 5. Okay, now let's check on the right side. From 184 going down to 174, the difference is 10, but going down, so it's negative 10. From 174 to 164, we're going down 10 units. From 164 to 154, we're going down 10 units. And from 154 to 144, we're going down 10 units. Great. Okay, so now we're gonna analyze what's going on here. Look, here I have plus 3, plus 5, plus 5, plus 5. But here everything is different. Do you think that if I have, on this one here, guys, 3 and negative 44. Okay, so on this one, the values are totally different. So I will have to check that one. And I will have to find the change on the y, remember, over the change on the x's. That's how we can find the m that we're going to use in the equation. So the change on the y over the change of the on the x's on the first difference will be negative 44 over 3. But then, guys, for these three values here, so the table can be a constant rate of change, I need to get the same value. But look, here all these values are the same, but here all the values are different. So do you think that when dividing this over this, am I gonna get the same answer? And of course not, because this value is different every time. So every time is gonna be a different answer. So we cannot choose A because the values here are totally different. Now let's check on B. Okay, for letter B, I'm gonna make some notes on the side. So I'm gonna write that right here. For B, I see that on the first values from the table, I have a difference on y over the difference on the x-axis. So I'm gonna check what is the first difference. The first difference is negative 24 over the first difference on the x-axis, which is positive 3 over positive 3. And you guys can tell me, what is 24 divided by 3? It's 8. Awesome. And that would be, what's a negative divided by a positive? Correct, it is negative. So this will give me negative 8. Now what about for all the other values? What would be the delta y? Well, it is always negative 40. And what about the change on the x's for all the other values is a positive 5. This one got it from the blue side and this one from the right side. And what's 40 divided by 8? You're very right. Is 8. And what is a negative divided by a positive? So that rate of change for table B is always the same, which is a negative 8. And that also matches with this negative 8 for the slope. The number that is next to the letter X, that's our M always, remember? This is our M. So looks like for B, the m is always -8. So this might be your answer. Do we have to check the other ones? Of course. Now let's check C. For C, I should always get the same answer when I divide the values on the y over the values on the x. See that, guys? But notice this one. Here, I will get -50 divided by +3. For this order pair, I will have to divide first -50 over 3. But the other times, all the other times, you see on the table, the value that I will have to figure will be -50 over 5, because that's the change that happened in the other values of the table. Do you believe that this and this value are equal? Of course not. If we divide by 3 and the same number we divide by 5, we're gonna get different answer. So the slope is not constant. It's not constant. And we can only pick relationships that have a constant rate of change. So we definitely cannot take C. We already said we cannot take A. B might be, but we have to check the answers here. Now we're gonna check D. For D, remember I have to check delta y over delta x. The delta y is what I get from the orange side, and the delta x is what I get from the left side on the x-axis. And one time, for this one here, guys, I will have to do -10 over +3. I'm gonna put it like this. But for all the other values, I'm gonna put those in green right here. For all these values, the delta y is -10, but the delta x, the change on the axis, is +5. Do you believe these two values will be the same? If we divide the same 10 by 3 or the same 10 by a 5, is that gonna be the same? No, it's not gonna be the same. So the slope is not constant. And then that makes this, that is not an option. So the only one that's gonna work is gonna be our choice B, because that rate of change should remain constant, and we figure the value here that we got this -8, and then it should be this one here. Now, how can we make sure that also that 200 is the right number that we can have there? Okay, one easy way is to do substitution, and we can do that substitution. You see how this equation is given, and we have y equals 200 minus a that multiplies x. And I'm going to do substitution with the table B, and I'm going to do substitution with one value. This one here is 180. So instead of y, I'm going to plug in 180. I'm getting this from the orange side. And that should be equals to 200 minus a that multiplies x. And for this value here, I have to use the same values in the same row, which means it's the same order pair. The value of x is a 2. So I got it from the blue side. See, guys? Okay, so then that means that 184 should be the same as 200 minus 16. And which in reality it is the same. If I subtract 200 minus 16, that's gonna give me 184. So you see here, this 184 is the same value that we got here, and when I did my operations, I got the same value right here. So this is like a proof. Just to make sure that it worked. We did substitution. Great, guys. Summarizing. If you have different tables and you want to figure which table matches with the equation, check the pattern. And if you see that the pattern is not consistent in the tables, you see, like here was plus 3, the change here was negative 44 over 3, but the delta y over the delta x is going to be different for all these values. Okay, so check the changes on the y over the changes on the x's, and they have to be consistent all across the table. Then pick that one, and to just make a proof like we did here, look on the right side, do substitution. Choose one order pair, means the two numbers in the same row, plug them in, do substitution, and the number on the left side must be equal to the number on the right side. Thank you so very much, guys. You did a great job.